So good morning class once again. Let us continue from where we have stopped last time. So we have started with the function of each and every layer in an OSI reference model. So as we have seen in the last class that there are seven OSI different layers, out of which let us start the individual function of each and every layer. So the first OSI layer starts with the physical layer. So as we discussed, physical layer basically work on or concentrate on the coordinating the functions between the bit stream over the physical media. So what physical layer generally do with is it work on several protocols, it works on several specifications which make sure that whatever the digital data that is received by the data link layer to the physical layer will be sent over a physical medium. So the conversion of data in digital form, that is 0 and 1 form, will be into an electrical form is the responsibility of this physical layer. So it specifies all the protocols related to it. Next please. So here you can see the data link layer, the data received is in the form of 1 and 0, and ultimately the output of physical layer, here we started with the conversion of data in the form of electrical signal through a transmission medium. Again, if we go for wired communication, there it can be into physical wired physical media, then obviously it will be in the form of electrical signal, but while if we go for a Wi-Fi connection, there it could be in the form of electromagnetic waves. Next please. Next. Now the next layer here is the data link layer. Now data link layer is just the layer above the physical layer and below the network layer. Now there are specific tasks that data link layer has to look for. The tasks are framing, physical addressing, flow control, error control and access control. Now if we categorize these 5 responsibility into 1 or 2 categories, we can say data link layer is responsible for data link control and access control. Now in order to go for data link control as well as access control, we go for framing of data. That means whatever the stream that is received from the physical media, when the receiver side is there, or from transmitting side, whatever the data received by the network layer, the physical layer is going to convert that data into number of frames. So number of bits combined together will be called as a frame. So the first responsibility of a data link layer, that will be framing, where several number of bits clubbed together to form a frame. Next responsibility as a data link layer, network layer and physical layer are the layers responsible for system to system communication, that is one port to another port communication is there, and that is why we need to go for defining the physical addresses. So physical addressing will be the second responsibility of data link layer. Then under data link control there are 2 responsibilities. One, if at all any kind of error occur in the communication over a media, then the detection of that error and correction will be the responsibility of data link layer, followed by flow control. Now there are several systems which will be taking part in communication. Every system will have its own specification with own the speed that system is going to be working. So obviously there will be some kind of mismatch in the speed of operation, and that is where the data link layer comes into the picture, where it work on flow control. So it makes sure that even though there are 2 dedicated systems at different speeds, let it be operating, but DLL make sure that the flow will be controlled from transmitting end to the receiving end. Then the last one is nothing but the access control. Now access control, or we can call it as a media access control, which simply indicates that if we are using a common channel, if a common path or a common link is being used by 2 systems or many systems, then DLL define who is going to access that particular channel. So access control is one of the very important responsibility that is there along with the data link layer. Next. So here those 5 responsibilities we have taken out, that it receive data from the network layer, then it will format that whatever the data received in the form of frames, then it will attach 2 kinds of header as well as trailer. So it will send a separate bits along with the data what it has received. The reason why we require to send the additional bits, because we need to take care of the error control, we need to take care of flow control, and then the access control. So all the assignment, all the required bits will be sent along with the data. Next. This is what is concluded. The data link layer is responsible for moving frame from hop to hop, that is system to system. Next. So this is how the entire view here. So from the end system to the another end system, in between, whatever the different formation of links are there. So here the role of the data link layer comes. So this is one more example. If system number 10 wish to have communication with system number 87, then along with this data, along with the information that is to be transmitted, source and destination addresses will be shared, plus there will be trailer shared, which will contain the other information or the control information, where start of frame, end of frame, error control, every data will be available. Next. Now next layer is the network layer. So network layer here is responsible for delivering the individual packet from source host to the destination host. Now what exactly is the difference between the DLL layer and the network layer? The scope now has become wider. That means generally if DLL is there, those systems will be part of a same network. But while we need to have connection with the system which is present in one network to the system which is present in some other network. So between the network to network connections, when it comes, the DLL layer will not be work over there. There we have to go for the internet. We need to get connected with the internet, or we need to get connected with the global network, and that is the reason why the network layer will come into the picture. Network layer makes sure that two hosts which belongs to the separate network can have communication with each other, and obviously when that is happened, obviously we need to go one step ahead from the physical addressing to the logical addressing. Now here it is explained, like between two systems, it is very much possible that those systems could be part of same network, or the system could be part of some other network as well. Next. So next layer to network layer is nothing but the transport layer. Now transport layer and layers below transport layer has a separation, like physical, data link and network layer. These three layers are responsible for host to host communication, that is from one system to the another system. But when we talk about layers, transport layer and layer above that are the process to process communication. That means there may be several processes running on one host to the several processes running on some other host. So transport layer and above layer deal with process to process communication. That means there may be several processes running on one system, and the destination system may run with several processes. Then application to application networking or application to application link establishment is the main role of transport layer and the above layer. Apart from the process to process communication, transport layer focuses on some other responsibilities as well, like service point addressing. That means the process directly to the port it will get connected with. The segmentation and the reassembly. So we have divided the data in the form of frames. Then we have data divided in the form of packets when we talk about network layer. But when we talk about transport layer, here we divide the data in the form of different segments. So we make different segments of data, and we again that will be at transmitting end, and at receiving end we again reassemble that particular data. Apart from that, it also focuses on the connection control, flow control and error control. Now flow control and error control is a bit different than that with the DLL layer. The reason being is here now we will talking about the global issue. That means system which are part of some other networks, there also we need to go for the flow and error control. Next please. Now what what exactly we understand by segmentation and reassembly? So whatever the data that we have received from the session layer, that entire huge amount of data, bulk amount of data will be divided into several segments, and then we give name to those numbers to those segments, and then the data will be transmitted. So a bulk amount of data will be divided into several segments. Now the reason doing this, or reason behind this, is as we will be following two different kinds of protocol that we will discuss later on when we reach to transport layer in detail. But there are two kinds of protocol, that is TCP and UDP. There we have to make sure that the entire bulk data, if we are transmitting, and if at all any kind of error occur, that entire data, block of data, we need not have to resend. So what we do generally is we divide that data into number of segments and then we transfer it. So if at all any error come in any one of the segment, then we can resend those segments instead of going for sending entire bulk data. So here it is just like we are dividing the data into small packets, small segments, and then send the individual segment. So if at all error occur in any of the segment, only that segment we can transmit, and it is bound to happen because transport layer, when we will go and see in detail when we reach to transport layer, but there are certain protocols in transport layer where the connection is we cannot give 100% guarantee of that particular connection. There is no end-to-end connection or a fixed path connection. There may be a time where the data packets will travel some, one data packet will travel some path, or another data will travel by some another path. So there is a case that certain segment will reach early, say segment we have divided into 1 to 10. So it may be the case that segment 10 will reach earlier than segment 1. So in such cases, we need to define those numbers to those segments and then access on that particular data. We'll go and see in detail when we reach there. Next. Then this is the reliable process-to-process delivery message, as we have discussed. This is host to host connection, which is responsibility of network layer and a layer below it. But there will be several processes running on one host. There will be several processes running on some different hosts. But in order to establish or make connection between two processes, we need to go for transport layer, and that is why it is called as process-to-process delivery system or process-to-process delivery layer. Next layer is the session layer. So here main part that is done by session layer is it provides synchronization between the connections. It makes sure that a session will be established between two processes, and at the same time it will make sure that at what time or where the session must be suspended or session must be stopped. So session establish and termination is the responsibility of session layer. Apart from that, maintaining the synchronization between the host or the transmitter and receiver is also the responsibility of session layer. And if we have to go for synchronization, we need to have or we need to add several synchronization bits in between. So whatever the data I receive from the presentation layer, like this is the transmitter, so whatever data I receive from presentation layer, there will be several segments made, and each of the segment we will add some synchronization bits so that a proper synchronization between transmitter and receiver can be achieved. Next is the presentation layer. Now it is responsible for translation, compression and encryption. So as I told, the network layer and above layers, where one system can have communication between another system which is part of some different network. So it could be very much possible that a computer system A, which is part of some southernmost area in the globe or in world, can have interconnection with the eastmost area in the world. So there could be a remote connection, there could be a remote connection between two individual hosts which are far away, far separated from one place to each other. Now if the hosts are that separated, it is very much possible that they may be using a different language, they may be working on a different platform, their configuration of the system may be different. So if the two hosts which are running on two different platforms, which are running on a different language, still communication could be possible, and that is made possible with the help of presentation layer. So it makes sure that whatever the communication happen, the translation rule, the compression rule, and most important is the encryption rule. As we will be connected with global network, there may be an issue of security of the data, and that security of the data will be taken care by this presentation layer, where with the help of encryption keys, it makes sure that the data will remain secure. Next. And last layer is nothing but the application layer. So as we have discussed earlier, the layer which is close to the user, the layer which is close to the human interface or with some machine to machine interface, when one machine is interacting with the another one, or one human is using that particular machine, application layer is very much important, because it connects one machine through that particular application. Say for example, if we are using a browser, then whatever the data that we enter on that particular browser, so browser here is an application. So the application layer take responsibility of all such things which connect a user, which connect a human to a machine. So application layer is responsible for providing service to the user or to the end user here, we can say. So there are several protocols like from email also, from browsing also, all taken care by this application layer. Next. So this is all about the different 7 layers and the OSI reference model, how it works. So let us go one by one in detail, and let us start with now chapter number 2, which deals with the data link layer. Just excuse me for a minute. So let us start with chapter number 2. Let us go through what are the contents of this chapter first. The title here is data link layer. Okay. So these are the contents. Now before we could get started with the content, let us revise one more time what are the responsibility of data link layer, because this chapter itself indicates what a data link layer and what are its responsibility, what are the different protocols it has. So let us start it again. Data link layer is basically responsible for framing. It makes different, it makes sure that all the bits will be clubbed together to form a frame. Is it working?
Yes, sir.
So it makes sure that all the bits will be clubbed together to form a frame. Then it also makes sure that the error, if at all it appear, will be taken care, will be detected and corrected. Followed by it also make sure that the flow will be maintained from the transmitting end to the receiving end, and lastly make sure that the access control, whatever the links that we will be using, that link will be accessed properly by each and every individual layer, the link which is common in use. Now let us go through what are the contents. First thing is framing. So what are the different ways in which we can form the frames? We will cover under this bit. Next is error detection and correction. Flow control methods. Now in this method there are several protocols. One is stop and wait protocol, sliding window protocol, piggybacking, followed by access control, that is collision oriented or collision based protocol, followed by Aloha, CSMA, CSMA CD, CSMA CA, and lastly is nothing but the HDLC frame format. Next. Now, as I said, broadly if we categorize responsibility of data link layer, then we have service. This will be common to all layers, that every layer is responsible for providing service to every layer above it, and the layer above network, this data link layer is the network layer. So its first responsibility is provide service to the network layer. Next responsibility is formation of frame. Next is error control, and lastly is the flow control. Next. Now, if we go for the functioning, so as I said, two important functions: data link control, in which error as well as flow control will be there, and lastly is nothing but the access control. Now, access control means there could be two systems which are working at different speeds. So DLL make sure that, data link layer make sure that all, even though the variety of the speed is there, still the communication will take place and entire data will be communicated without bottleneck condition or without loss of data. So this is what is written here: providing service, dealing with the transmission errors, regulating the data flow, so irrespective of slow sender or slow receiver. Next. Now when we go for coding, let us come back to coding, or let us start with the coding first. What do you understand by coding? What do you understand by generating a code? Now, coding here means whatever the data that we will be transmitting, that we will be receiving from the network layer, that data need to be transmitted to the next system, that is physical layer, and through physical layer it will transmit to the host side. So data it received from the network layer need to reach to the some other data link layer on some system or some node connected on the same network. Now, if data is to be transmitted, but we have to take care, the data link has to take care that there will not be any kind of error took place. If at all error took place, it could be detected and corrective action should be taken. There could be, there should not be any kind of flow mismatch. So flow rate has to be maintained. Now, if we want to do this, only sending the data will not be sufficient. So along with the data, we have to send several redundant bits. So now, what do you understand by coding? Now, coding means whatever the data that you are sending referred as a data word, and along with that data, additional bits will be sent named as redundant bit, which are derived from the same data, which are linked with this data only, and data along with redundant bits itself combined call it as a code word. So data word here, if we refer it as a K, then if we add redundant bits R, then K plus R is nothing but your code word N. So in a simple word, we will not be sending the data alone. We will be sending some additional bits with those data, and those bits only make sure that error correction detection responsibility will be taken and the data will reach to the destination side. So code word in short has data along with redundant bits. Next. So let us take a simple example here. If we go for a code for error detection, if we decided that this is the data that we want to transfer, a 2-bit data. So if 2-bit data is there, could be variety of combination. It could be 00, 01, 10 and 11. If this data we need to transmit, we need to generate code word for this data word. These are the data words 00, 01, 10, 11. From this data words, we will generate code words first. Now, how to generate code words? Code words will be generated by adding redundant bits. But how to generate redundant bits? Now, redundant bits are having certain link with the data word. Now, in this case, let us consider the simple parity check. Here, if data is 00, let us count number of ones present here. If number of ones present are odd, then we will go for 1. If number of ones present are 0 or in even numbers, then we will go for a 0 adding. Now here first data is 00, so number of ones present are 0, so we will go ahead with 0. In 01, number of ones present is 1, which is an odd number, so obviously we will add a digit 1 to it. Here also 10, number of ones present is 1, so here we will add, as odd number is there 1. 11, number of ones present are 2, which is even number, and that is why it is added as 0. So this way, these redundant bit, one redundant we have added, which is based on parity, whether number of ones are in even number or odd number, depending upon that we have formed this code word. Now if we wish to transmit the data from network, this data link layer, then we will not be transmitting data words, we will be transmitting the code words. Now if such a code word, if we receive at the receiving end or at the data link layer present at the receiver side, what could be the different possibilities that we can check? If we want to send, let's take simple example, if you want to send data number 2, that is 0, 1, then we have to send a code that is 0, 1, 1. If 0, 1, 1 is received as it is without any correction, that means without any error occurred into it, then there won't be any problem. If 0, 1, 1 is appeared at the receiver side, it will just verify what data it is and then it will be accepted as it is. What if 0, 1, 1 is received? That means instead of 0, 1, 1, if we receive 0, 0, 1, then obviously first 2 bits, we all know that these are the data bits which is also conveyed to the receiver side. So first 2 bits are the data words. From this, what kind of parity that we will be getting? Here number of ones present are 0. So obviously next parity bit generated or next redundant bit generated must be 0. But instead of a 0, the data here is 1. That means 100% error has occurred and that error will be detected here. Next, what if 0, 0, 0 is received instead of 0, 0, 1, 1, which is having only 1 bit error up to this case, that can be easily detected. But here, if 2 bits has error, that last 2 bits changed from 0, 1, 1 to 0, 0, 0, that means the data bit also changed and the redundant bit also changed. If such change is there, then obviously 100% error has occurred, but it will not be detected. So this is one example through which I would like to convey to you that even though we add different checks, even though we go for coding of the data, but unless we go for 100% guarantee of what data that we are transmitting, we may not be able to detect the error 100%. That is, in this case we have detected the error because it was only a single bit error. So single bit error is easily detected. But here, if 2 bit error is generated, we may not be in a position to detect that particular error. And even though error is there, the data received as it is as 0, 0, which is wrong. Got it? So this is the way we go for the coding of the data. One of the example where we have gone for a 2-bit data added into it. Next. Now let us take one more example here. If we want to go for, along with error detection, if we want to go for error correction as well. Now if we wish to go for error correction, we have to go for 2 things. One, we have to make sure that how error can be detected. Apart from detection of the error, we also need to go for where exactly the error has took place. And then we have to identify the location and make correction into that or make changes into it. So if 2 tasks are there, by adding a simple 1-bit redundant will not be sufficient. So here we follow a coding method via which what we decided is, instead of going for a 2-bit data word, we go for 2-bit data word only, but from 2-bit data word only, but to generate a code word we use 3 redundant bits. So here if we observe, 2-bit data word is there, but the code word size is 5-bit. That means here value of k, that is number of bits in a data, are 2, but redundant bits here for one data is 3-bit redundancy. So that is why data word is 0, 0, but code word is 0, 0, 0, 0, 0. In short, for a 2-bit data we have added a 3-bit redundancy. So now instead of 2-bit data we will be transmitting a 5-bit data. So which is a very heavy task because our data transmission is 2-bit per data, but now we are transmitting 5-bit per data, which is a heavy task. We don't generally go for such kind of method, but as an example I would like to express this to you. Now if we go for this kind of code word, it is now possible to identify the error as well as to make sure that how we can correct the error as well. Now let us, for this case, consider that in this particular channel, only 1 bit error could maximum took place. So let us consider case that if at all error took place, it will be a 1 bit or a single bit error only. So let us consider few of the cases. Let us say that we want to transmit a 0-1 data, that is again same data number 2. So obviously in order to transmit 0-1, we will not send a data word, we will be send the code word assigned to it, that is nothing but 0-1-0-1-1. So instead of transmitting only 0-1, we are going to here transmit 0-1, 0-1 and 1. So 5-bit data that we have transmitted. So there could be variety of combination that I can get at the receiving end. If we assume that 1-bit error is occurred and comparing the data with the received all valid code words at the receiver, we can find the correction. Now how it is possible? Why this conclusion is made over here? So let us consider that here some kind of error has occurred. So that means instead of 0-1 data that is transmitted, that is nothing but code word transmitted 0-1-0-1-1. Instead of this data, if receiver side, if we receive say example 0-1-0-0-1. So if we receive one error, one data change in 4th bit here, if we start from MSB side 0-1-0-0-1, if this data we receive at the receiver side, how we are going to identify if at all error occur or not? So this code word here will be checked, will be verified along with all the possible code words which will be there available at the receiver side. And by considering that there could be maximum 1 bit error possible, we can verify the received data, that is 0-1-0-0-1, along with all the different combinations, all the different possible combination of code words, and then ultimately we can reach to the conclusion that whatever received has an error occurred in bit number 4. So this way, if we go for higher number of redundant bits, it is possible not only to detect the error but also to correct the error is very much possible. Next. But again, logically speaking, if more and more number of redundant bits we will be adding, the bandwidth will keep on increasing. Then next concept here is called as Hamming word or Hamming distance. So Hamming distance means what? If we are taking some data word or some data frame, say 00 is number 1 word and it is compared with 1 word. Though Hamming distance here indicate that number of differences that those two digits have in each other. Say for example, next please. So if here, if data is first data is 000, next is 011. So here if we observe first 2 bits of are 00, next 0, this side is 0, this side is 1, here it is 0, here it is 1. So we have 2 datas with the differences, and that is why the Hamming distance here is 2. So logically speaking, Hamming distance between the pair of words is nothing but number of different bits available here. If we go back. So Hamming distance, how we can define? Hamming distance between 2 words is number of differences between corresponding bits. So bits, those are different in values, is nothing but your Hamming distance. Next please. So you can take here the next example. If we go for finding the Hamming distance between this 5-bit data word, here you will have 01101, 10110. Here number of bits change will be bit number 2, bit number 4 and bit number 5. So 2, 4, 5, that means 3 places the error, the 3 places the difference is there, and that is why the Hamming distance is 3. Next. Then minimum Hamming distance. Now minimum Hamming distance is the smallest Hamming distance between the all possible pairs in set of words. So instead of comparing only 2 words, if we have a set of words, there are say 5, 6, 8 words, and in all those 5, 6, 8 words, if we try all the combinations, finding out all the Hamming distances, the minimum distance is known as minimum Hamming distance. Let us take a simple example for this. So if we see this combination here, if we are going for a 3-bit data, then 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0. So if we tried off all the combinations, here we can see maximum or minimum, whatever the Hamming distance available is only 2. So all the different pairs of data available here, combination of group of data is available, but everywhere the Hamming distance is 2, and that is why D means, that is minimum Hamming distance is also 2. In next example, there will be some variations. Now here if you observe 5-bit data is there, we have 1, 2, 3, 4 data pairs where Hamming distance is 3 and 2 data combinations where Hamming distance is 4. So there, here the minimum Hamming distance will be 3. So D min value for this entire group of data will be only 3. Now Hamming distance and minimum Hamming distance is an important parameter when we go for error detection and correction. Next is the linear block codes. Next. Now what linear block codes are? Well, it is explained with the help of this block diagram only. So what exactly we do here? As I have explained to you, what is code word? So code word is nothing but whatever the data word that we have received, but that data word we will not be transmitting. That from that data word we will be going for generating some of the redundant bits. Then the data word itself along with redundant bits will be a code word, and we will be transmitting that code word over a unreliable transmission. So when this data, that is data word along with redundant bits, will reach to the receiver side, we will assume here that whatever code word that we have received, transmitted there, may not be received here. So here we start with A3, A2, A1, A0, and here we will start with B3, B2, B1, B0. The redundant bit there is R0, but we have received here say Q0. So whatever is transmitted there may or may not be reached to the destination as it is. It may have some changes. So this linear block code system, what exactly it defines is, if such unreliable transmission is there, some unreliable channel is there, then we will generate a code word from the data word with the help of a generator, and that key we will be sharing to the receiver side, and then from the same code word that we have received at the receiver, it may be correct, it may not be correct, but this code word, instead of passing on to the receiver side posted directly, we will be passing it to a checker, where the checker will work on this particular data. It will make some operation of this data which is similar operation to that of a generator, and then based on what operation is done on the generator, it will generate some syndrome. Now syndrome is the result of this checker. Syndrome information will be given to the decision logic, which will make sure that what value of syndrome we have received, if it is correct one, then this data will be transmitted to the data word as it is. If it is wrong one, then that data will be discarded. In short, linear block code make sure that if data word is available for the transmission at the transmitting end, we will generate a code word from it. Code word will be transmitting at the decoder side or at the receiver side. Code word will undergo an operation for checker, and based on result of it, which is known as syndrome, we will make sure that data is to be transmitted or is not to be transmitted, whether it will be discarded or it will be sent to the receiver side. So that decision will be taken care of. Back side, please. So this is what is defined in linear block code, where all the block codes used today along with the subset called as linear block code is a code in which the XOR condition or modulo to addition of valid code word creates another valid code words. Next. So before that, let us take a simple example here. A simple parity check coding is there. So that means the generator operation is nothing but your parity check operation. So data words are defined with the black color, code words generated with the pink color. So these black colors are the data words. So what is done here, depending upon parity of the data word, last digit or last bit will be changed. Say if it is 0000, then obviously code word will be 0 because number of ones present are 0 here. In second case, 3 zeros followed by 1, so number of ones present is 1, so therefore odd number, so odd parity, that means last bit, parity bit will be set as high, and depending upon this similar operation we have taken and we have find out the different code words. So how from this data code word is generated, or from this data code word is generated? 1, 2, 3, 4. 4 ones are there, 4 is an even number, so value here is 0. 1, 2, 3. 3 ones are there, which is an odd number, so value here is 1. So that way code words are generated. In short, generator here is nothing but parity check generator. Next. So let us take prior to that. Let us take this example. If data word to be transmitted is 1011, obviously we will not transfer this data word. Instead of that, we will transmit 1011 and parity bit as 1 or redundant bit as 1. So code word that we transmit is 10111. Next. So there could be variety of different cases that could happen. One, no error occur. That whatever the transmitted code word is there, as it is, if we receive at the receiver side, it will be accepted. Syndrome generated will be positive, and accordingly the data word will be created. Next is a single bit or one bit error changes, that is error has happened in A1 bit. So data word what we have transmitted, okay, so data word is 10111. So A1 bit is bit number 4. So if at all it got changed, one code word is changed, so the received code word will now become but number 3rd will get changed. So received will be 10 instead of 1 here. If we receive a 0, so 10011 if we receive, then syndrome here will be 1, which is wrong, because if number of ones present here is 1, 2 and 3, obviously it will result into 1, but we were expecting it to be 0, but still it is 1. So the error will be detected and no data word is created. That means whatever we receive, we will straight away discard it. Third is one single bit error occur or changes in R0. So let us take the same example. Last bit here, this bit is R0. So 1011 is there. If R0 changes from R0 from 1 it becomes 0, then received code word will be 10110. Now the syndrome here is 1, so no data word is created. So even though the data what we have transmitted is reached correctly, data word is reached correctly, but the parity bit has changed. So parity bit, even though it changed, it will consider it as an error occurred and data will be discarded. So it will detect the error based on, because what it is going to do ultimately is, if it is received the data as 10111, it will calculate its own value of, it will calculate its the value of the parity for first 4 bits, and if accordingly the parity generated is not matched with the last bit that is received, because here if you change the last bit, we were expecting it to be 1, but received is 0, that means error will be there, and if error is there, it will be discarded. Next, the condition number 4 is, if an error occur in R0 and at the same time some data also get changed. So if 2 different kinds of error is occur, then syndrome is equal to 0. So now this may be the condition occur here, that even though the data transmitted is wrong, but because 2 errors have occurred, the generator or the checker will not identify the error that has been occurred and the data word which is wrong, but still it will be created. So here in case number 4, even though error occur, it will not be detected. Then lastly, last case here is 3 bits change. Let us say A3, A2 as well as A1 got changed. So if 3 bit value is changed, we may occur to a condition, or we may face a condition that because of 3 bits have changed, the parity which is wrong, that also become right. Say for example here, the code word, if 3 bits got changed, instead of 1 0 1 1 1, if we receive 0 1 0 1 1, if we work on these two, the error may not be detected, but still the data the syndrome will become 1 and data will not be created. Now back. So from this example, we may reach to the conclusion that if a simple parity check, if we work on, it guarantee to detect one single error, or it can also detect odd number of errors, like as happened in this case. Even though 3 bits error took place, which is easily identified by this particular case. That is, this value after 3 bits got changed. If we check the parity of this will become 0, but this value here is 1, and that is why the error has detected and data word is not created. So in short, here the error has detected. In earlier case, error has detected when single bit error was there. So we can reach to a conclusion that simple parity check guarantee to detect 1 bit error or a odd bit error, but if multiple errors or even bit errors are there, it may not be detected by this particular algorithm or this particular method. Next, so simple parity check can detect an odd number of errors only. So let us stop here, and in next class we will be going for the Hamming code method and the CRC method.